Hello again. So it occurred to me whilst I was just quickly lunching, it occurred to me that we've been going for, I think, 2 hours on the previous stream, give or take, and we drew a square. Can't decide if that's good or bad. I mean, at least we drew a square. I guess it's better to think of it as we created a whole program, read some ROM files, loaded up a sprite. Yeah, but we drew a square. Be cool if we could, and this is I guess where it gets quite difficult. Be cool if we could navigate around that square. That would be cool. So for that, I'm going to lean on something I was doing over the last couple of days, which was figuring out a camera system. I think I put in system, yeah, camera movement. So again, there's a bunch of stuff in here I don't think I need. And I think it's probably widely wrong as well. So I think what I'll do, yeah, okay, what I'm going to do is I'm going to create systems folder. Let's yeah, let's create a systems folder. Was that in source? Yeah, it is in source. Okay, so new folder, systems, and then in here, apparently we called it camera movement, but I guess that describes what it does. So we should stick with that. Camera movement, and that of course is a Rust file. And then this is what I had copied and pasted. Like, admittedly, this was quite heavily borrowed from another project. So an open source project, but another project nonetheless. I kind of want to get rid of everything I don't understand. So okay, so this is creating a struct called camera movement system. Then we are finding a type of system data, or were, inside of here, which apparently we're using. That's what we return. I'm gonna keep it because it looks like we are actually using it. Then this runs. I happen to know this runs once per frame, I think. So this one was curious. So this takes the amount of time that's passed since the last frame. And then the idea is that this allows you to move at a constant speed. Excuse me, even if your frame rate is going up or down or all over the place, your movement can be consistent if you know how much time has passed since the last frame, and then you can adjust the speed, as in how far you've moved. In fact, yeah, this is not a speed, this is a factor of how far you've moved the camera from one frame to another. And then they've got a for loop, so they're going through cameras, names, and transforms. So I'm guessing this, and this are arrays or vectors that we're looping through. And as we loop through them, oh, hang on, there's a dot join there. So we loop through all cameras, all names, and all transformations. And if name equals main camera, I'm not sure why there's a for loop here. This to me doesn't make the greatest of sense. But name comes from, what does join do? Have a look. Oh, it doesn't give me any hover information. That's not so helpful. but we're not using cameras, so that doesn't get a variable name. We are using the name of the camera, and we are using transformation somewhere. Oh, that becomes the transform. Okay, this sort of makes sense to me, I think. And then this was, I mean, this is just not needed. And then if we're doing something on our main camera, and we only have one camera at the moment, so I don't think we even need to check the name. Then we can say, well, we can check actually. We can say if camera move up, like what is this? So this doesn't make a lot of sense initially. Input.handler.action is down. So if camera move up, whatever button that translates to is pushed down, then we should move upwards. I think that makes sense. I'm going to go one further, and I'm going to suggest that actually if we're moving up, we shouldn't move down. And if we're moving left, I don't think we should move right. I think one or the other should win. And again, you can move forward or you can move backwards. You can't do both simultaneously, and I don't think the buttons should cancel each other out. Yeah, I'm happy with that. So systems, right? We just kind of skipped over those. We should definitely go back to here. Go back up to systems. So system is where the logic of the game is executed. Okay, so we've got the logic of the camera movement system here. Consists of a struct implementing a function executed on every iteration of the game loop, taking as an argument data about the game. So cameras, names, all of this, I guess. Or is this thing argument about well, okay, I'm momentarily confused over where the data about the game data is, but fine. Yeah, quite confused. And we return a type, but what do we pass in? Okay, maybe it doesn't need any data about the game because we're just moving where the camera is. So this system will, on every iteration of the game loop, print hello in the console. Fine. In our case, we're going to print run camera movement system. I think that's fine. Did I click something and it just changed? Maybe I didn't. Okay, let's read all of this. So accessing the context of the game. In the definition of a system, the trait requires you to define a system data. Okay, we've got one of those. Yep, confirmed system data. This type defines what data the system will be provided with on each call of its run method. System data is only to carry information accessible to multiple systems. Data local to a system is usually stored in the system struct itself instead. I guess probably up here, that would be the struct. There's a read expect, a read storage. Okay, so we've got a read storage for camera, a read storage for named, write storage for transform. Oh, this is making a bit more sense now. Read input handler. And then we read the time. Right. So this is maybe, or it is, the arguments. Okay. Yep, that makes a lot of sense. I'm happy with that. So in this case, they're just reading the time, but in our case, we're doing a whole bunch of stuff. So actually, if we're not using the camera, why bother passing it in? I think there's a to-do there. Maybe drop the camera if we don't need it. Fine. Getting a component of a specific entry. Did I just skip something? Once you have access to a storage, you can use them in different ways. So we can read or write storage, basically. And there we're getting transform. Hang on. Sometimes it can be useful to get a component of the storage for a specific entity. This can easily be done by using the get or for mutable storages, get mute methods. Where is that in use? I see here transforms.getMute. We're seemingly not doing that. Getting all entities with specific components. Most of the time you'll want to perform logic on all entities with a specific component, or even all entities with a selection of components. This is possible using the join method. Oh yeah, we spotted that. Yeah. Did I just click on something and it's... Yes. I don't know what happened, right? I went away for 10-15 minutes, ate some food, came back, and now I've just lost the ability to click on web browsers. It's crazy. So this is possible using the join method, which we've just discovered is here. You may be familiar with joining operations if you ever worked with databases. Yes, I have. The join method takes multiple storages and iterates over all of the entities that have a component in each of those storages. Okay, so it's important actually that we do have cameras there because we only want to access the storage of things that are cameras. Okay, it works like an AND gate and it will return an iterator containing a tuple of all the requested components if they are all on the same entity. So if it's a camera, if it has a name, and if it has transformations attached to it, I guess. Needless to say that you can use it with anyone. Hang on a minute. Components we considered. Fine. Needless to say, you can use it only with one storage to iterate over all entities with a specific component. Keep in mind the join method is only available by importing amethyst ECS join, which apparently we're bringing in a whole lot of stuff, not just join. Keep in mind that the join method is only available by... Yep, we did that. So does this compile? Just straight away, let's see if this happily compiles. Strangely, it compiled very quickly. Maybe it didn't feel any need to compile this file. It sees it's not in use. But no, it should complain that this is not in use because nothing calls run. I am confused. Let's break it. I mean, let's put something in here that's just atrociously wrong. So it is not bothering to compile this file. Furious. This system will make all entities with both a transform with a positive y coordinate and a falling object tag component fall by 0.1 unit per game loop iteration. That's pretty neat. Getting entities that have some components but not others. No, I think we're okay at the moment. I think we're getting all the things that we want. Manipulating the structure of entities, creating new entities in the system. Yeah, we don't need to do that either yet. But oh, when this? Whoa, hang on. Maybe we do need this. So this is spawn enemies. So maybe we want spawn life forms. One thing at a time, though. One thing at a time. Got to remember this. This is looking super useful. So what do we need to do? So we create these systems, and then how do we actually use these systems? So here they've created some states, some actions, gameplay, another state. Then they've specified a system here, but I don't see how they're actually... How is this being called? I wonder if we need to put a use at the top of one of these. So I know there's that one. Maybe it's not going to cover it. So I think, partly because I went through this pain before, we need a mod in our systems folder for a start. So this is essentially, if you're not familiar with Rust, this will give you a way of accessing modules that you've defined within other files. And you need one of these potentially in each directory that contains modules. So the thing is, this is not actually, well, I guess it's not defined specifically with the word module in here, but I think we can turn the entire file into a module, which is basically, well, that's just done. So that's fine. Then I think if we go to main, I suspect I'm using, oh yeah, I'm bringing in mod systems. If I switch back away from my proof of concept and towards the code that we actually want to use, I think we can say I want to bring in the module systems, and let's have a look and see if that now complains. Okay, it's having a good, it's actually having a go at compiling it this time. Good. But I suspect it might either crash out. Okay, it didn't crash out, but I haven't got any buttons that do anything, and it still displays our square. So I'm going to commit this, I think, just so we've got a waypoint here, and I'm going to say, so git add source systems, and then git add source main, and say, let's just check we're happy with this. So we do need the camera because we've just understood that that works as a kind of like an and. And I think I'm happy with the rest of this. We need a main camera. Why do I keep doing that? I've missed the word add. Look at that. Just like git source main. Just do something with it, please, git. Okay, let's commit. Yeah, we can commit this now. Added camera system not working yet, but does compile. You should use a language that does not take an entire stream to compile. Oh, it doesn't. We can compile in a few seconds. I'd be glad to hear. But you know, it's a trade-off. I like the fact that it compiles, gives us type safety, bit of speed. What do you normally develop in? I'm going to go and pronounce that as Trollkong. What do you normally develop in? What else do we have going on here? So somewhere, I'm guessing we're using this camera system. Again, I'm just, oh, the camera movement, sorry. Again, we are in proof of concept. We're not in the code that we were just writing. This is one that I'd kind of prepared earlier, as it were, which is a mashup of okay, so use Go, Python, C, and TypeScript. That's a nice mixture. And camera movement. Yes, that's what we were doing. So I was trying to find out where we actually kick off this camera movement system. Where do we add it to the program? You tried Rust, but dependency resolving took 30 minutes. What on earth? How many dependencies? What was that for? And how long ago was this? Because a new version of Rust comes out every 6 weeks. Camera movements. So yeah, I think we go back to our main version, the one we've been working on today. So we've got a load sprite sheet, fine, which we use inside of, so I think this is the simple state that we need to update. So I'm just going to switch back. So again, this is the simple state from a proof of concept horrendous mashup from the previous day. Let's just see what we've got. So in here, we're setting up a world. Yep, setting up a world. We load up the sprite sheet. We're doing that. And then at the moment, we just register our square life form and then initialize our square life form. So in this case, we're initializing the camera after we initialize, I guess that would be life forms. Oh no, there we go. So we're doing that. So what else do we need? Now we invent something called a dispatcher. Or don't invent it. Now we set it up using dispatcher builder. This is not immediately clear what this is doing. So let's copy and paste it, see if it compiles, and then see if we can explain it. Maybe we just skip 1 and 2 and see if we can find the word dispatcher. Here we go, dispatcher. Dispatchers are the heart of the ECS infrastructure. They're the executors that decide when the systems will be executed. Okay, that's cool because we've just added a camera system. We want it to be executed. When a dispatcher is created, it is associated with the system that it will execute. So this is the system. And it respects mutability rules. Fine, I don't think that'll be a problem. Let's try and compile it. Cool, so we've run into some problems. So use of undeclared type or module times 2. So let's head back to our terrible proof of concept, and we can see that we're going to need a few things. We're going to need dispatcher builder. And so first up, let's add that. So this is going into our life. Oh no, shred. Let's put that. Does that get rid of one of our errors? Yep. Next one, use of undeclared type or module camera movement. Okay, so this is because we've created our own module in the systems folder called camera movement, which is all well and good, but we haven't then brought it into our scope. So we've got mod systems, but we must be including, I go back to the proof of concept. Yeah, here we go. Use create systems camera movement. So what this is doing is this. Sorry, I was just having a momentary thought as to whether we could change the syntax on that. I don't think we can. So this loads up from the namespace of crate, i.e. the beginning of this project, the root of our project. It then looks in the systems module for something called camera movement, sees that there's a file there called camera movement that doesn't seem to contain any other modules, and loads that up as a camera movement module, which should mean one less error. Cool, so now we're just getting some warnings about arc thread pull. So if I have a look in here, what are we doing to get that? So that comes from core arc thread pull. So if I go back to today's version of this game, we can add arc thread pull here. Go run. No arc thread pull in core transform. Of course, because actually it's not in transform. It is just all by itself on hire in the namespace. Okay, so what do we got now? No field dispatcher on type gameplay state. So that is complaining that our struct gameplay state, wherever that is, here, doesn't have a dispatcher attribute. So I could type it out, but I'm going to copy and paste it. If I go back to here, search for the word dispatcher. I think. Yeah, there it is. We can just copy this. And what this is doing is adding to our, that's our proof of concept version, back to today's version. This makes the dispatcher attribute publicly available so we can read it, but also says it is a type of dispatcher with two variables that are, I guess they get static lifetimes. I.e. it should get rid of that error. Probably produce a new one now though. Try adding a comma. Yes. Try basic syntax, Craig. Try that. Cool. So we're still seeing not found in this scope. That's from dispatcher. So I'll go back to our proof of concept and we should see up here somewhere. It'll mention maybe in this one, dispatcher. Yeah, so ECS prelude dispatcher. We need to bring that into scope as well. So, yep, just add dispatcher to the end of there. And slowly work our way through the compile errors until eventually this runs. Gameplay state, missing dispatcher. So this is where we're saying, hey, here's a new gameplay state, and initially life forms are empty. But we've also said in the definition of our struct, which I'm just finding, we've added this new dispatcher attribute, but we haven't specified a dispatcher attribute. So if I go down to line 174, right here, we should be saying dispatcher is equal to something. Now, I don't actually know what that should be equal to. I remember some pain trying to figure it out, but if I go back to my proof of concept and I head down to here, maybe it's in here. Yes, so dispatcher can be equal to a new dispatcher, basically. This is, we don't have one, so build a new one. So let's go back to here. This is today's code. This is starting to look a bit gnarly, so I think I might take this out and say gameplay state. And I'm going to say gameplay state equals an instantiated struct with a dispatcher that's equal to an empty or new dispatcher and 0 life forms because we don't have any life forms yet. Let's see if that runs. Oh, nearly. Cannot borrow as mutable. Okay, so this is a Rust thing. Cannot borrow world as mutable as it is not declared as mutable. That's possibly reasonably easy to fix. So if I go up to line 126, this is essentially saying world is not writable, right? You can't make any changes to this world variable. If I add mute, then suddenly it can be mutated, i.e. changed. And that's a nice handy Rust warning there saying, actually, if this is a variable, then you should be using underscores. Otherwise it looks like it's, you know, something a bit more interesting, like a a new struct or something. Okay, well that compiled but didn't really do anything, which is fine. I think I know why. But I just want to deal with the warning that it gave us. So here, this could become snake case, and then the compiler will cease to shout at us. Then I think I'm going to hit commit. Then we'll see if we can get the final piece of this puzzle going, which will mean potentially we'll be able to move around in our little world. Okay, it compiles. Happy. So we can say git commit. Now loading camera system into, and what were we loading it into? They gave a good via a dispatcher. Yes, so we have a new dispatcher that we load. We give it a new thread, i.e. a computation thread. We load up our camera movement system into a dispatcher. Then we set our self, because we're a simple state, and we remember that a simple state is an extension of gameplay state, which has a dispatcher and a life forms. And we set our version of dispatcher to this dispatcher we've just created, and then we set it up by passing in a world that is mutable. Okay, so to answer my own question, now loading camera system into dispatcher. That is what we're doing. But it still doesn't do anything, right? It doesn't do anything of interest. So there's one other thing that we need to do, and that is where we had bindings for the display, i.e. here's the title of our game and here's the size of the screen. We've also got, sorry, not bindings, where we've got a RON file, a Rust object notation file for the display, we can also have one for key bindings. So this can sit in the config, and I'm going to call it key bindings dot Rust object notation, and that's going to look a bit like this. So camera move up, so if I push the up key, then it triggers camera move up. And if you remember on this page, we've got these things called camera move up, camera move down, camera move left, right, forward, backward. They are set here. So up and down is up and down, left and right is left and right, and backwards and forward are left shift and rather awkwardly right shift. I'm not really sure I like that. I think up should be W. I think down should be S. I think A should be left. I think D should be right. And then, no, I don't even, how have I forgotten basic game controls? Okay, let's stick with the default for the moment. We'll fix that in a minute because my brain's struggling with basics of how a standard game moves around. It's A, W, S, and D, and then left. No, I can't remember. No, then you roll with the right hand keys, right? That's how normal space games work. Man, I'm out of touch with the last 30 years of gaming. Anyway, so the point is, this is the proof of concept. Let's go back to our today version. This is our today version. So we have this key bindings. Now I'm guessing that doesn't just magically end up in here. We have to load it up, right? We have to load up those key bindings. So in here we called them bindings. So I'm guessing in the project somewhere, if I search for the word bindings, they appear all over the shop actually. Okay, so this is using bindings. This is our camera system. Mentions it a couple of times. And here we have a bindings path. Let's just copy this, take it to the right place. This is in the main thread again. And it's happening before we build game data apparently. where's the main thread? I've lost the main thread. I've really lost the main thread. Where's it gone? There it is. Okay, so this goes in before game data. So we've got bindings.rust object notation, but it's not, it's key bindings now because I changed the name of it. Then we load up something called input bundle, and with basically the stuff we can find in this file, which we found in keybindings.ron, load them into input bundle. All right, that's all very well and good. Does it compile? I'm not sure it will. Nope. Use of undeclared type on module input bundle. So if I head on over to our proof of concept from the other day, search for input bundle, we can see that there's a bunch of stuff here under input. If I head to today's version of the code, I guess after today I'll be able to throw away the old proof of concept, right? If I head to today's version of the code, then that should now bring into scope our ability to use keys. Let's see if we end up with a game. Now that there is warning us, gone, but that was essentially warning us that we've added input. By the way, I'm just testing the keys. Nothing's happening. There was a warning way up there. It's basically saying, "Hey, you're using input, input something, whatever it was." See that there's definitely too much in this file because I keep getting lost. Very, very lost in this file right now. Where is main? There it is. We've added this. We've added input bundle, sorry, but then we're not loading it, and that's probably because we need to do a with bundle thing here. All right. I could have a look through the manual, but I'm not going to because again, I've got it in our proof of concept. I know the input bundle is here, and we just need to load it up like this. So this is today's version of Game of Life. We're going to add input bundle before we do transforms. I don't actually know if it makes a difference which order which order these are in. Maybe it does. Let's try and run this. This might actually work, by the way. This might now work. I don't quite know what it's going to look like with this square. But it'd be neat if we can suddenly fly around in 3D space. Okay. Well, I'm pushing buttons and absolutely nothing is happening. And I remember why. We set up a camera in here. Let me find it. So here we set up a camera and we don't give it a name, but in our camera movements file we're quite specific and we say if the camera's name is main camera. So we need to figure out how to give it a name. Again, I could check the manual, but I happen to have one here. Or not. Maybe it's in this file. Yeah, it's in this file somewhere. Okay, so this time, after we create an entity, let's get out of the proof of concept from the other day. Yeah, after we create an entity, we can give it a name. This one we're going to call main camera. And now, I really hope this works, because if this doesn't work, I am actually out of ideas. I don't know what is, if this doesn't work, then it's going to be a bit of investigation to figure out what. Okay. Not seeing anything. If I put the mouse like just on the edge of that square, I think I moved the mouse. Hang on. That is astonishingly difficult. Okay, it's about, the point is I'm pushing buttons Nothing is moving. Okay, so it's going to be a bit of debug. So what have we got going on here? Run camera movement system. So we should have seen that happening over and over again, and we didn't, which means it's not loading up the system. So why would this be? It could be to do with the world. Maybe we create another world and overwrite too early. So when we initialize life forms, we have world passed in. Let's just go down from the top. Okay, so there's some inclusions, we don't care. Setting up some structs, we don't care. Initialize life forms, we pass in a world and return a world, so we're not creating any new ones. Load sprite sheet, we pass in a world, we're not creating any new ones. Initialize camera. World is, oh yeah, again we're returning the world, so that's fine. Now simple state. Now this we do actually create. No, we're not creating a world. That's getting it from data. So there's no new world created there. In the main function, I'm surprised that we're not creating a new world anywhere. If I go back to my proof of concept app, I'm reasonably sure a quick scan through here. This is what I mean, like registering paddle. Like in this proof of concept app, it's honestly just doing all kinds of weird and wonderful things. Old real work. Hang on. Oh, maybe I'm not creating one here either. That's surprising. Okay, what else have we got? So we've got, I notice on simple state, we've got a update function that uses this dispatcher. But in my version of this today, in simple state, we've got an on start, but we don't have a second function. So I wonder if this is required, because you can see here it says dispatch and then it runs the dispatcher. I think that might be the problem. Let's see. This is where Troll King is being proved right, that it does take a while to load or to compile. Okay, camera main camera, update. Oh, it says Tetland simple state. Is that me just blindly copying something in? Yeah, look at that. Just call that simple state. Whoa, okay, we have camera movement. Can I go forward? This is looking, look at this. We're moving the camera. This is fantastic. Okay, can I take that off screen? I mean, I should be able to. Okay, and can I back up as well? Yeah. Okay. I mean, this is, I'm committing this. This is great. Git diff. Let's have a look. Actually, that's not. That's going to take too long. Let's have a look at git status. So we want to add the keyboard bindings. And I want to add that as well. That's all of our code changes. I think I'm going to commit that. Camera now movable. Yay. That is exciting commit. Throws out a lot of debug, but that's fine. Well, all right, what next? I mean, at this point, I think I throw away the proof of concept because we've pretty much, I think, gone above and beyond what that was doing. We've got fairly clean code, although it's... No, I'm not going to... No, it's not that clean, actually. Pretty jumbled in a main file. We should separate that, but that's okay. The point is it works. So what do we want to do now? It doesn't look very 3D. That's the only thing. So we've got transform, move up, move down. So at this point, I do want to look at transform and say, well, what is that? If I go here, so this is transform.rs inside of amethyst. So within here, I should be able to see what functions I can do. So I can set a scale. Oh, I can face towards and then I can give it an object. That's pretty neat. Translation, rotation. Yes, let's do that. Returns a reference to the rotation. Oh, hang on. Maybe that doesn't, maybe that's like, how are we rotated currently in space rather than please rotate. Append translation, prepend translation, move forward, move back. So these are the ones that we're using, right? Move right, move left. So what do these prepend things do? Move a distance along an axis relative to the parent's orientation or the global orientation if no parent exists. So with this one, global orientation. For example, if the object is rotated 45 degrees about its y-axis, then you prepend a translation along the z-axis. It will still move along the parent z-axis rather than its local z-axis, which is rotated 40 degrees. The object is rotated about its y-axis. Then you prepend a translation along the z-axis. I think I understand. Oh, I see. Move a distance along an axis relative to the local orientation. Okay, this is where 3D space gets difficult, but I believe what we want to do is, instead of moving left and moving right, so for left, I'm gonna try rotating. So we're gonna do a transform, prepend translation along. So instead of moving left, prepend translation along, and then it was saying it expects a copy of itself, sure. A direction, which is a vector, and a distance. Oh, maybe, no, hang on. Maybe we don't want translation along. Maybe we want just translation. Move relative to its current position, but the parents or global if no parent exists. For example, if the object is rotated 45 degrees and it's y. No, I don't think that's right either. That returns a mutable reference to the rotation. But what if we want to rotate? Let's keep going. Let's keep going. I don't think that functions right. Append rotation. Multiply rotation about the x-axis or x-axis. I.e. perform a rotation about the parent's x-axis or the global x-axis if no parent exists. Then the delta angle is specified. Well, I did say it was going to be an advanced game of life. We still need a name for it, by the way. That was half the point of this stream, is to try and name it. So I'm open to suggestions. Set rotation. Now we're talking. So rotation along the x would be left and right. So we probably... Okay, so if we go back to here. So instead, I think we want set rotation y-axis. No, we want x-axis, sorry. Then what does it expect? That's an entire angle. Oh, whereas I think... Oh, okay. Okay, I think we want append rotation x-axis. So append rotation x-axis. Then it's asking for copy of itself and then a delta angle. I don't know what a delta angle is. I guess we're going to find out. Well, I know what a delta is. That's a difference. I know what an angle is. So I guess it wants an angle with which it's going to turn. But what I don't know is... Oh, it's a float. Okay, so we could try 0.2. Maybe that'll spin us. But yeah, sorry. Then the first thing it wanted was a copy of self. Now I can only imagine that transform is itself. So let's try that. That did not work. This function takes one parameter, but two were... Oh, okay, I wasn't listening. End rotation. I mean... Okay. So it doesn't want a copy of itself. Does it just want 0.2? That looks like it might compile. We can rotate. This is going to be quite interesting. Because one thing I don't know is we've drawn a square, but I don't know what it actually is in 3D space. Like, is it genuinely a square? So in theory, if I push the left... Hang on. All right, that's not quite what I was expecting. But okay, and 0.2 is too much. But this is... Let's go with 0.02, right? Cool, okay. So maybe in the next half an hour or so we can get this. Like, this would be quite neat. Actually, second stream, and we're... Yeah, look at that. That's definitely looking like it exists in 3D space. Good. So I'm getting super excited about a square. I know. So I'm trying to think. So in a game, what are the normal game controllers for a 3D shooter? 3D shooter game controllers. No, it wouldn't be a 3D shooter. It'd be a space shooter or something. Not game controllers. 3D spacecraft game keyboard bindings. Bindings for Kerbal. Maybe Kerbal would have a good suggestion. Yeah, okay, so in their case, pitch and yaw is okay. That's possibly too complicated. I need a 3D game. Anyone play any 3D space games? Space Engine. Yeah, maybe Space Engineers. That's a game I've played. I enjoyed that. Movement. This is crazy that I can't. Movement, walking, flying, fine. That doesn't help at all. I want to know what A, W, S, and D do. You know what? Let's I reckon W should be forward, S should be backwards, A and D should be look left and right. That's got to be the normal way of doing it. Everyone can laugh about the fact that I'm having trouble with this later, but that's genuinely true. So, and then camera move left and move right, I don't think would be a thing. No, okay. Up, move down. So those would be fine. Camera move forward, that would be W. Camera move backward would be S. Camera what are we going to call this? Look left? I think it should be look left. Should be A. And look right. Be D. Then we need to add those. So now I think we'll stick with our rule that you can't do two things at the same time. So let's take, so this can go back to what it was. So we can do, so this is up, down. This is literally move up or down. This is move left or right. And this is move forward, backward. And then this is look left and look right. So curiously then, so when we, so instead of move, we should have look, and instead of move, again, we should have look. So curiously, append rotation to X was not the right one. Maybe append rotation to Y, and then I guess that should be the opposite. It should still be Y. Let's try compiling that. Let's see what happens. Okay, so I'm going to look left. That seems to be doing the exact opposite of what I expected. I'm going to look right. Oh, no, I'm not looking. That's moving. Okay, let's try looking. Okay, those need to be... No, those are perfect. If I look left... We are so far away. We are so far away from the square. How big is this square? I think we're starting to see the problem here. The scale of this universe is too vast. Or our speed is too slow, I don't know which. But yeah, I mean, this is 3D, right? So somehow, eventually, I think, yeah, I've gone past it. Hang on. Does that have a, no, it's infinitely thin. Look at that, there. Infinitely thin. But that's pretty cool. We've created a 3D thing in space. I'm happy with that. Let's commit this for sure. Commit, yes. So what can we do now? We can look left and look right. Look left and look right implemented with camera. Implemented and working. Cool. Feel like we should probably push this up to a project soon. I might do that just after the stream. What do we want to do now? So we've got a 3D game. I guess we want to draw. We should probably draw a 3D object, right? So we've got a square. Well, let's go for a cube. Or anything actually. I don't care. Just so long as it's 3D. Load the sprite sheet necessary to render the graphics. So somewhere we load so yeah, we've got our life form. Apparently it's only 1 high. We must start so far away from it. Doesn't make any sense. Yeah, it doesn't make it will do. One of these numbers is wrong, or maybe several of these numbers are wrong, right? So correctly position the life form. So it ends up 100 away. And load a sprite sheet. So we do that. Loading the sprite sheet is fine, I think. We initialize a camera, that's fine. So load the sprite sheet. Don't we initialize an object somewhere? Forget where it is now. Somewhere I was sure we initialized the object and loaded it into the world. Can't find where. Was that it? No. There. World.register life form. Then we initialize life forms. How about, so it's gotta be in here. So set translation XYZ. Assign the sprites for the life form. Sprite.render. Sprite sheet, so that it gets a copy of the sprite sheet. Paddle is the first sprite in the sprite sheet. That shouldn't say paddle. That should say life form. The word paddle appear anywhere else? No. Okay, good. Git commit. I'm just going to check actually. Is that the only thing that changed? Yeah. Corrected note to say life form. Yep. Create a life form. So with sprite render, with life form new, transform. So set translation XYZ. But this is a 2D object. So maybe is everything 2D and we have to figure out a way to draw. Okay, this seems like it might be quite a complicated one. And possibly a good place to stop this stream actually. We can come back to it because it's been a good day. So just at the end of the stream, I'm just going to show you where we got to with this. And I'm going to push this up into a project now. I'll get it up on GitHub. It'll be totally open source as usual. Any issues you find with it, great on GitHub, and I'll take a look. But yeah, look at that. We have a 3D square. That is definitely a 3D square. Very happy with that. That'll do for now. Right. Thanks all. Until next time. Cheers.